So what would be this first one? A equals what? 100? Remember, we're raising it to that power, right? We're not multiplying. We're doing 10 times what would give us 1,000. 10 times 10 times 10. Look at how many zeros we got, right? So this would be A equals 3. 14. What about this one? 10 to what power would give us 1? 10 to what power would give us 1? Well, 10 to the first power would give us 10, right? And we want to get 1. So how would we get rid of this 0? We could go back 1, right? So 10 to what power would give us 1? There you go. All right. This next one, we haven't seen this in a little while. Remember, this is taking the square root of something, but raising it to the third power. So really, we're taking the square root of 1,000. Does anybody know what the square root of 1,000? And this is not like testing your memory. Like go into your calculator, type in 1,000, and then take the square root of it. You go what? 31.62. So it's not like a whole number, right? Yeah. Okay, so we're going to leave it underneath this radical. Now, what about this one? A little harder. 10 to what power would give us 500? We see that this number out front is no longer 1. That makes our job a little bit harder, right? Well, we know that 10 to the first power is 10. We know that 10 to the second power is 100. 10 to the third power is 1,000. So D is going to have to be in between about 2 and 3, right? Okay, so 2.5-ish. Okay. Now, logs are going to help us with trying to find them. Okay. So we're going to say it's roughly 2.5, roughly. Okay, so he said, looking at this table, everything that's behind the decimal going down is the same, right? Okay, is there any other? Look at the bottom of the table. And look straight across. Do you notice anything? Nothing. All right, so we have 10 and 1, 100 and 2, 1,000 and 3, 1,000 and 4. So this row is our only whole numbers, right? Whole numbers are on the bottom. Okay. Let's focus in on when the output is a whole number. So we're looking at that bottom row. Using these values, we can write the equation. So log of base 10 of 10 equals 1. Log of base 10 of 100 equals 2. Log of base 10 of 1,000 equals 3. What do you notice? Okay, so 10 the first power would equal 10, right? Okay, what about this one? Would equal 100. 10 to the third power would be 1,000. So this is how we are connecting the exponent and the base and then trying to find that number. Okay. So reading the equation, log of base 10 of 10 equals 1. Interpreting the equation, what exponent of 10 needs to get to which we've already established that. 10 to the first would give me 10. 10 to the second would give me 100. 10 to the third would give me 1,000. Right here, we've got log of 1,000 equals 3. Reading the equation, we have log of base 10 of 1,000 equals 3. What exponent of 10 is needed to get to 1,000? 3. Based on the previous example, see if you can fill in the blank. Log of base 5 of 125 equals what? So 5 to what power would equal 125? 5 to what power would equal 125? We know that 5 to the first is 5. 5 to the second is 25. 5 to the third is what? Okay, so 3. So log of base 5 of 125 equals 3. And we already said what exponent of 5 is needed to get 125, and you answered it was 3. Desmos doesn't carry? Whatever. Okay, so if we go into Desmos, and we come in here, and we hit this little keyboard button thing down at the bottom left-hand corner, we go to functions, and we're looking for logs. There's 2 different options. We're working out a base 10, so that means that we're going to pick this top right-hand corner. Okay, what was the first one? It was like log of what? Okay, pause. Wait, what? Log of 10, right? Like A was log of 10. Okay, so when I type that in, it gives me the answer of 1, right? Okay, so let's check the other ones. Let's see if we did those right. We got log of 1. That gives me 0. Okay. Log of 1/10 gives me, nope, not 1/10. Log of 0.1 gives me -1. So C is going to give me -1, okay? Log of 1,000 or 10,000, I can't read. That's going to give me 4. So D is going to be 4. And then E is going to be -2. And log of 100 is going to give me 2. Okay, so we got a couple of them. Some of those decimals kind of trips us up a little bit. So let's write it out on our paper. The first one is 1. The next one is 0. What was the next one? Good. The next one is 4, -2, and 2. Okay. Now we're going to order these from least to greatest. What's the smallest number on here? -2. Okay, so E is going to go over here. And then what's the next number? -1, that's C. The next number is 0, so that's going to be B. Next number is A. Then F. And then D. I don't know why we don't have enough boxes, but I just work here. Okay, let's go ahead and look at the next page or next slide. Nope, because there's not a next slide. Go ahead and flip the page. Okay, now we're actually getting into like the important parts of logs. So if you need to evaluate a log with base 10, use the log button in the calculator. Remember that if you don't see a base next to the log, it's base 10. So can you go ahead and evaluate these? Go ahead, take your calculator. You can use Desmos, just like we went over, okay? I don't know if iPhones do logs. Yes, they do. You can do them also on your iPhone. Okay, so go ahead and take a second. Try A, B, and C. Okay, well, too bad. Okay, the log of base 10 of 818, what did you get? 2.9-ish? Yeah, hurry up. All right, we're about log of 0.0032. Oh, we're not there yet. Okay, take a second. Negative 2.4. Okay, that's okay. We're giving rough estimates. Log of 1 divided by 25. What'd you get? I got 1.39, roughly. You got negative? Okay. All right, so now we're going to talk about base E. So this is called the natural logs. So if you need to evaluate a log with a base E, use the ln button in the calculator. Okay, so remember, log of base E is the same thing as ln. Okay, and you do have a button that already does that. So go ahead and take a second, and you can do it on your iPhone too. If you do ln of 2, what do you get? Okay, 0.69. Okay, what about ln of E? So you're going to type E first and then hit that ln button, and that's going to give you 1. What about ln of 3? Good. Okay. So recall from what we just talked about, how the relationship between exponential and logarithmic equation produces equivalent equations. Okay, so 10 to the 4th power equals 10,000. Log of base 10 of 10,000 equals 4. 3 to the 2nd power equals 9. Log of base 3 of 9 equals 2. I want to kind of go through, I think we started talking about this one day, the little circle of life trick that I use to write these out. If I'm given a log and I want to write it as an exponential, I'm going to start at my base, go to the outside, and finish over here at the y. So what I mean by that is if I want to write this as an exponential, I'm going to say 10 to the 4th power equals 10,000. You can also go the opposite way. If you want to go from exponential to log, you're going to start at your base, go to the outside, finish at your exponent. So log of base 3 of 9 equals 2. Okay. The little acronym I use for this is BOY, or you can say BAE. You can be like B-A-E. All right, let's talk. So we already went through basically this. We can go from exponential to log. Okay, so we see on the left-hand side, we have b to the y equals x, 2 to the 3rd equals 8. And this is saying raising 2 to the exponent of 3 gives 8. Okay, over here, we have log of base b of x equals y. Log of base 2 of 8 equals 3. So this is saying the exponent to which we raise a base 2 to get 8 is 3. So what about this next one? How do we get from log of base 2 of 16 equals 4? How do we write that in exponential form? How do we write this one in exponential form? And the faster you talk to me, the faster we get through this. So over here, we got this log. We want to get exponential. So we're going to start at our base, go to the outside, finish over here. So 2 to the 4th power equals 16. Okay. Over here, we're going to try to write this in log form. So remember, we're always going to start with our base, go to the outside, finish at our exponent. So we have log of base 5 of 1 over 25 equals negative 2. Okay, so here's a logarithmic equation. How do we read this in words? Like, read this little line right here. Okay, good try, good try. Okay, so we're gonna say log of base 3 of 81 equals x. You want to write that out. All right, how do we write this in exponential form? Take a second, see if you can write this out using that circle of life. All right, so how do we write this in exponential? So we start at our base. We go to the outside and we finish our exponent. So that's the order that we're going to write it in. So 3 to the x equals 81. Now, how do we read the exponential form? 3 to the power of x equals 81. Okay, so looking at this exponential form, I don't know what number this is going to be. So what I can do is I can take the log form and I can go type it into Desmos. So let's take a moment and let's type this in. If I go into function, I scroll all the way down to logs, I'm going to use this log of base A. So we had log of base 3 of 81. And what number did that give me? 4. Okay, so this is going to give me x equals 4. So sometimes the log form is helpful to solve, and sometimes the exponential is helpful to solve. So we thought that the log form, because we can use a calculator. Okay, or earlier today, we saw this equation. Use what you know about the relationship between exponentials and logs to find the exact value of b. So we made like educated guess last time. I want you to take this and write it in log form and then tell me what the answer is. On the next page, educated guess. Yeah. Great. So let's go ahead and write this in log form. So remember, we started our base, go to the outside, and then finish at the exponent. So log of base 10 of 500 equals b. Now I'm going to take this and I'm going to plug it into Desmos, because Desmos carries. We're going to go to functions. We're going to go down to logs. And this time we're going to hit this button because we're in base 10. We're going to say of 500, and that is roughly 2.6989. So that is B equals 2.6989. Ta-da! How do I rewrite this guy in exponent form? I start from base, then go where? Outside, and then 25, right? So we got 5 to the x equals 25. So 5 to what power would give us 25? 2. Woo! Yeah. Okay, on the next one, we've got 5 to what power would equal 20? Again, how I got that is I started at my base, I go to my outside, and then finish over here. All right, so what is x going to equal roughly? Okay, to like not have it exact. Like in between 2 and 3, right? Okay, so we're going to have like 2 point, maybe 2-ish. Okay, so you know how we said base 10 is what we work out of, right? So we got like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we start that process over again. We got 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then we keep going. So we can change these to be in base 10. Okay. So if you're given a logarithmic expression that does not have a base 10 or e, and converting to exponential form does not help, we can solve these expressions by change of base. Okay. So right here, we have log of base b of y. The way we do this in change of base form is we say log of y divided by log of b. So same thing is going to have it over here. Log of base 2 of 15 is going to turn to log of 15 divided by log of 2. Now, fortunately, your calculator in Desmos, you can literally just plug this in and it solves it for you. But back in the day, when I was in high school, you had to type this in with change of base formula. That's why this is something that you learn. Okay. So consider yourselves lucky. Okay. Huh? Because like, you know, like it was like 2010 to, or I'm sorry, 2009 to 2012. We had to like type it in like this. And if you got something crazy, yeah. Anyways. All right, log of base 3 of 45. So how am I going to write this in change of base form? Well, I'm going to say log of this big number, which is 45, divided by log of the little number. Okay, and so now we can type that into our calculator as if we couldn't already do this in Desmos, but it's fine. I'm not salty at all. 45 log, and then divided by. I got like 3.46-ish. So I got 3.46. Can you try writing B in change of base form and C in change of base form? So how would I write this guy in change of base form? Log of this bigger number. And what I mean by bigger, I mean like actual size. So 0.5, and we're going to divide it by log of 5. Okay. And when we plug that into our calculator, what are we going to get? Log of 0.5 divided by log of 5. Log of 0.5 divided by log of 5. That's going to give us something roughly around negative 0.43-ish, right? Okay, on this one, we've got log of 392 divided by log of 15. Exponential and logarithmic knowledge to isolate the variables below. So how would I write this guy in exponential form? The faster you talk to me, the faster we get done. How do I write this in exponential form? What's the base on this guy? 9. It's going to be 10. If it's not written, we assume that it's 10. Okay. Now, how do we write this in exponential form? Where do we start? We started our base. 10 to the 4th power equals 8. What's 10 to the 4th power? 10,000. Okay, this next one's a little tricky. Remember, ln is the same thing as saying log of base e. So how do I write this in exponential form? E to the b equals 15. Remember, e is 2.718, right? Now, it might be easier to just go ahead and write ln of 15. So if we put that in our calculator, we're going to get b equals 2.71, roughly. Okay. What about this next one? How do I write this in log form? I start at my base, which is E, go outside, finish at my exponent. So we have log of base E of 30 equals C. Well, remember, log of base E is the same thing as ln. So we're going to say ln of 30, which is C equals 3.4. Can you try this last one? Put it in log form. All right, so in this next one, we're going to write this in log form. Yeah, there you go. And when you read this, it's going to be log of base 5. Okay. And when we plug that in, we're going to get some number. So I haven't done this yet. You did what? Uh-huh. Okay. That's okay. So it's like 2.24, right? Yay. Okay. Go ahead and flip the page. And I want you to go ahead and do the stop and jot. Okay. You are going to put this on this. No, I'm not gonna use sticky. Yeah, go ahead. Okay, so you're gonna go ahead and fill in the blanks. So what you're gonna do is you're gonna write it in exponential and then make sure that you write it in log. So whichever one is empty, that's what you're going to do. So what I mean is, like on this first one, I would write this out in log form. And that would be log of base 7 of 343 equals 3. If I was doing the next one, I would do it in exponential form. So I want you to go ahead and fill in these 3 blanks. On this next one, we're going to write this out in exponential form. So this is going to be 5 to the 4th power equals 625. Yay. Okay, on the next one, we're going to get log of base 3 of 243 equals 5. And on the last one, we're going to have 1/2 raised to the 3rd equals 1/8. Yeah. So. Thanks, guys. Okay, so sometimes they give you it in word form. I don't know why they would do this, but they can. So on the last slide, it says write 2 equations, one in exponential, one in log, to represent each equation or each question. So looking at that last box, that creating equations, it says, what exponent do we raise the number 3 to get 81? So when we write this, nope, go back. Sorry. I'll wait. Okay, so on this one, what is this equation going to look like? Well, we have, what exponent do we raise 3? So 3 to what power would give us 81? Now, can we write this in log form? Yeah. Okay, that's going to be log of base 3 of 81 equals x. Okay, can you try B? Can you write it in log form? The next. Okay, so we've got log of base 2 of 128 equals x. How do I write this in exponential? Fantastic. Ta-da! Yay.